Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Hardian Riansah and my partner Muhammad Abdul Khadir Koranhak. And now we will going to explain our experiment, and the title is indirect bleaching of low grade or nickel using fungal metabolic acid generated by Aspergillus niger. Before we start our presentation, I'm very grateful to Miss Raptri to give her time so we can tell you guys about our experiment, what we are going to do. Here is an outline that we will present to you in the next few moments. For the first is preface. The preface that contain about the background, the purpose of the text, and the main problem. The second is literature review. In this section, we will explain about basic theory in our experiment. The third is research method, and in this section we will explain about the flow diagram in our experiment and tools and material what we used in this experiment. And the last one is reference. For the first is preface. There is background. We check 4 points in our background. There is the increasing of demand, the depletion of high grade ore, abundance of low grade ore, and abundance biodiversity. You guys can see in our PowerPoint there is a diagram from Geologinesia which telling us about the nickel consumption and steel production in the world from year to year. Recorded by 2009 to now, nickel consumption in the world will always increase, and it is required the nickel production in the world should be increased too. And because that thing, the high grade ore of nickel will always decrease from year to year, and because it is continuously being mined, which the low grade ore of nickel it's not used as a mining material because there is become a uneconomical material. And in our country, Indonesia has an abundant biodiversity because Indonesia flanked by 2 oceans and 2 continents, and Indonesia close the equator too. For this 4 things become a background for our experiment. There is a bleaching process using a fungal metabolic agent Aspergillus niger. The second preface is the purpose of our experiment. The purpose of our experiment, there is extracting nickel from low grade ore with a bleaching method using fungal metabolic agent by the fungal Aspergillus niger. The third preface, there is a main problem. In our experiment, we check 4 points to become our main problem, and the first one is what the meaning of bleaching and what factor influence it. And the second is what is the optimal temperature, particle size, and the fluid density in this bleaching process. And the last one is what is the highest percentage of recovery that can be generated from this bleaching process. And the last preface is hypothesis. Hypothesis is an estimate in our experiment that will be conducted. And in our experiment, there is 2 points will become our hypothesis. For the first is organic acid product by fungal metabolics can produce high percent extraction. And second is the smallest particle size and high temperature in this experiment can produce the best percent recovery.
Okay, thank you. Now I'm going to explain about basic knowledge, nickel laterite ore. So almost of research in hydrometallurgical process about nickel is leading to sulfides ore, and the another type of ores like carbonates and silicates are unfortunately is left behind. As you can see in this slide, there is a picture that's showing the differences between the humid climate and drier climate about nickel laterite ore. So the limonite and saprolite is much more in the humid climate like in Indonesia. And the table here showing me that the nickel percent of the limonite and saprolite is very low. So there are so much low grade nickel laterite in this country, Indonesia. We have to process them with a beneficial one. Okay, next is about bioleaching. What is bioleaching? Bioleaching is the extraction of metals from the ore through the use of living organism. So as we can see in this slide, the bioleaching is divided into 3 types of process. The first is one-step bioleaching, the second is two-step, and the last is indirect bioleaching. The one-step and two steps are direct bioleaching. So if it's one step, the organism will be added together with the ores at the same time. And if it's two steps, the organism will put in first until it produces the organic acid, and then we put in the ore. For indirect bioleaching, we just add in the organic acid with the ore, so we not put in the microorganism or the organism to the vessel. We only put the organic acids and the ore at the same time. Okay, next. Bioleaching is also divided into 2 based on their organism. They are fungal and bacterial. Both of these organisms is produce some organic acid that we will use for the leaching as well. So the bacterial is also divided into 3 types. The first type is autotroph bacterial, and the second one is heterotroph bacterial, and the third one is mesotroph bacterial. For the autotroph bacteria, they can make their own food. Heterotroph, they need some additional nutrients. And the last, mesotroph, they can do both. They can make their own food, and also they need more additional nutrients. So in this case, we are not using bacteria, but we are using the fungal. So there are 3 types of fungus that have been used in bioleaching nickel research. The first one is Praesylium sp, the second one is Aspergillus niger, and the last is Praesylium chrysogenum. In this case, in this research, we are using the Aspergillus niger because Aspergillus niger can be found so many in nature, exactly in Indonesia, and it can be produced in lab so easy, so we can use that Aspergillus niger for our bioleaching. And the Aspergillus niger is widely used commercial for producing the citric acid, gluconic acid, and they are producing so many enzymes such as amylase, pectinase, and cellulase. So we are using the Aspergillus niger as well. The Praesylium sp and Praesylium chrysogenum is run not well enough in the last research, so we are not using them again. We are using the Aspergillus niger. Okay, next. What is the factor that affected bioleaching? So there are 5 factors that affected bioleaching. The first one is pulp density, and then time, temperature, particle size, and the last one is acidity. So in mineral processing, the amount of solids in pulp typically ranging from 10 until 25% by weight, it has a marked effect on recovery rate of minerals. So pulp density is absolutely affecting the bioleaching. Okay, the second one is time. The more time we use, the more percent recovery we will get. The third is temperature. The higher temperature we have, so the process is more faster than the cold temperature. Next is particle size. The smaller particle size, so the bigger we'll get the bigger of the surface, so the reactions is more often with the smaller particle size. It also will affecting the bioleaching process. So the last is acidity level, pH. It is affected bioleaching, especially for the biogeneration process of metabolism the fungus. The acidity level pH have to be in 5 so that we can know if the acids organics is being produced, it will get more acid. The level of pH is going to be lower than 5, so we can make the acidity level is to be our parameters of the organic acid that produced. Okay.
And in this section, there is a percent extraction of nickel. You guys can see in our PowerPoint, there is a formula about the percent metal extraction. The formula percent metal extraction, there is a ratio of leach metal and metal contained in ores by weight multiplied 100%. So for example, there is iron Fe as impurities of nickel ore. So the formulas become leach metal, there is nickel, and the metal contained in ores, there is a nickel and iron multiplied 100%. And the other example, there is a magnesium as a impurities of nickel ore, and the formulas become leach metal, there is nickel, and the metal contained in ores, there is a nickel and magnesium multiplied 100%. The next is reset method. There is a preparation ore flow diagram. For the first, limonite and separate ore being crushing and grinding, which is useful to reducing the size of the limonite and separate ore. After the combination process, the next process is screening. At screening size at minus 250 and plus 177 micron and minus 177 plus 149 micron and minus 149 plus 75 micron. And after the process of screening, the next process is testing using XRD and XRF to find out the composition of the limonite and separate ore, and then recording the data and then finish. Next is the making the metabolism of fungal Aspergillus niger flow diagram. For the first, there is an Allen Mayer, and then adding 150 ml potato dextrose and 300 ml tofuous water. The function of the adding potato dextrose, there is potato dextrose will become a place where the Aspergillus niger to grow and making metabolism. For the tofuous water, there is will become an environment for the Aspergillus niger to grow and making metabolism. And the next step is the adding 1 mole of NaOH for increase the pH at 5, and then perform autoclave at 121 degrees Celsius with 20 minutes for the sterile the Erlenmeyer and the solution. The next step is the perform cooling with room temperature, and then adding natural carbon as nutrition is tapioca. The tapioca will become a food to Aspergillus niger to grow and making metabolism. And the next step is the adding some mineral variation. The mineral variation, there is a 0.2 magnesium sulfate, 0.1 mangan sulfate, and then 0.3 ammonium sulfate. And the next step is the adding 10% Aspergillus niger, and then allow it to stand for the 30 days at 240 rpm and check periodically. And then data collection is the pH and HPLC analysis. HPLC analysis, there is an high performance liquid chromatography, and the function of the HPLC analysis, there is a will to find out the composition of the liquid in the Erlenmeyer, and then finish.
Okay, thank you. So I'm back again. I will explain about bioleaching nickel limonite and saprolite flow chart. So first thing first, you have to prepare 10 5-neck glass vessel. The size is 2000 milliliters, and then for the first process we put 500 milliliters organic acid to the vessel, and then we vary the limonite and saprolite ore based on their particle size. In this research I am using 3 size. The first one is 177 microns, and then the second one is 149 microns, and the third one is 75 microns. So there are three particle size. Okay, after we put in the 3 particle size, limonite and saprolite, we incubate them, the vessel, for 24 hours in 400 rpm with magnetic stirrer, and then we get the result. Okay, for the second process, it is the same as the first process. The difference is only at the variable of limonite and saprolite. In this second process, the difference is based on their pulp density. Okay, there are 2 types of pulp density. The first one is 1.7%, and the second is 2.6% of pulp density. So after we variate them, incubate them for 24 hours, 400 rpm with magnetic stirrer, same, and we get the result. Okay, the third process is using the first and the second result as the best parameter. So the result is we use to varying the limonite and saprolite at the temperature, based on the temperature. So in this research we use 3 temperature. The first is 25 degrees Celsius, the second is 65, and the last is 95 degrees Celsius. Okay, next slide. In every process, in 24 hours, we have to retrieve data in 10 seconds, 20, 30, 60, 120, 240, 720, and the last is 1440 seconds, which is minutes, which is 24 hours. In every trial, in every process, the process 1, process 2, and process 3. And for knowing the content, knowing the composition of the sample, we're using the AS testing. Okay, After that, we observe the data, study the literature, and we have the conclusion as well. Okay, now what are tools and materials that we use in bio-leaching nickel? For the tools, there are 5-neck glass vessel, hot plate, baker glass, autoclave, and testing equipment like XRD, XRF, AS, and then digital scales, reaction tube, Erlenmeyer, and the last is electric stove. But for your information, 5-neck glass vessel is put in the bath, leaching bath. In the leaching bath is usually can contain 6 glass vessel. Okay, for the materials, there are 2 in the fungal metabolism and in bio-leaching nickel. So in the metabolism of fungal, we need the tofu wastewater for keeping the pH of the agar potato dextrose, and the second one is absolutely the Aspergillus niger, the fungus, and the third is potato dextrose broth to making the PDA, and the last is cassava starch for the organic carbon that Aspergillus niger needs. And for the bio-leaching nickel, we absolutely need 2 particles of this, the limonite and saprolite nickel laterite. So here's my references, and thank you very much.